Some time ago, I posted an article saying that most people do their leg extensions in a suboptimal manner. You would think, what can you possibly do wrong during a leg extension? But there are a few things you can do wrong. One is the range of motion, which most people don't do fully. But secondly, and that's the aspect of this video, is that they don't lean back. We have this idea that good technique is always, military posture. I actually did a video on this for my last video on that military posture during an overhead press is also not ideal technique. And also during a leg extension, military posture, sitting fully upright, 90-degree angle, is actually very suboptimal because it does not allow you to involve the rectus femoris to the full extent. So the rectus femoris is a muscle of the quads, in the middle of the quads here. And when you want to activate this muscle, you have to take into account that it's biarticulate. So it crosses the hip and the knee. And as a result of that, it shortens when you lift up the leg because it's now contracting at the hip. And if I now want to contract it at the knee as well, so I'm shortening it at the hip and I'm also shortening it at the knee, then this happens. So it doesn't go up any further than that. You can try it yourself, try this right now. You cannot fully straighten your leg when you're flexing the hip. Of course, I can fully straighten my leg right now, but when my leg is fully flexed, the hip is flexed, you can't do it anymore. That's called active insufficiency. The rectus femoris is literally too short. The actin myosin parts of the muscle are too bunched up to form effective cross bridges anymore, and you cannot perform the movement. In a less extreme scenario, when the muscle is not so bunched up that you literally cannot perform the movement anymore, then you still cannot effectively form cross bridges, which means you cannot effectively perform an exercise. You cannot effectively generate muscle tension. If you cannot effectively generate muscle tension, then you can't effectively provide stimulus for muscle hypertrophy because mechanical tension on the muscle is the primary stimulus, probably the only stimulus actually based on the research we have so far for muscle growth. So the Japanese, maybe they saw this, maybe they didn't, maybe they came up with it on their own. In any case, they thought, this only theory, so we validate. And that's what they did. And they did a super cool study. Actually, I'm super excited about this study because they did something that I wanted to do for a long time. I'm going to talk about that in the second part of the video. But first, let's just get to the main findings and what they actually did. They had a group of bodybuilders. Yes, bodybuilders, not your average untrained subjects, postmenopausal women or something. No, bodybuilders. They had them perform the leg extension in 3 different manners on 3 different visits, which you can see here. One time they did it kind of a lying leg extension. They had some of these machines. I think Vince Granda had one of these machines that was actually pretty cool, based on, I presume, the same rationale that you would involve the rectus femoris more when you are leaning back. And one time leaning back almost 45 degrees, 40 degrees in this study. So that's like this. This is typically how I recommend it to clients. Set the leg extension seat way back and then you're leaning back. You're kind of like this, 45-degree angle or so. That's how I've always coached it. So that's one of the conditions here. And then the other was 80 degrees, which is like upright, about how I'm sitting right now. Almost 90 degrees, so almost fully upright. Many leg extension machines actually have you at a full 90-degree angle when you sit fully upright. So it's even more than in this study. And then they measured muscle activity using MRI. MRI is a better magnetic resonance imaging, is a better method than EMG for a lot of purposes, including this study, because it doesn't have many of the limitations. In particular, that it's easier to measure the muscle activation of deep muscles. Now, you may be wondering, how on earth can an MRI scanner measure muscle activation? But it actually can do quite well. Now, this is super simplified. Basically, when you exercise, there are fluid changes that occur in a muscle, and the MRI scanner can pick up on that. It's called a T2 change, the change in the T2 level. Here you can see an example of what that looks like. An area that lights up more, there's more change in the fluid balance, and that is a metric or a measure of muscle activation. What they also did, and this is the second part of the study that I'll touch on after the main findings, is they also measured the subjective muscle activation of the bodybuilders, and then they checked if the feelings of the bodybuilders matched with objective reality. Now, first, let's get to the main findings. Here's what they found. For one, the 1RMs were exactly as I predicted, bigger when you're leaning back. However, they were a bit lower when you were fully leaning back. So fully reclined, lying down was not ideal based on the 1RM values. And strength in this case is actually a very good measure of the exercise effectiveness. That's not always the case, but in this case it is, because It's a measure of the total amount of musculature you can involve. If you can involve more musculature, in this case, in particular, the rectus femoris of the quad, the middle of the quad, then you can move more weight. So the more weight you can lift is actually a measure of the total amount of muscle tension generated, which is what we want. Muscle activation showed the same pattern as strength, roughly. They found here, you can see it, that proximal, middle and distal rectus femoris values, you can see that in all the conditions, the middle bars, which is hip flexion angle of 40 degrees, which is thus about leaning like this, 45-degree angle, was better than leaning at 80 degrees, which is fully upright, or 0 degrees, which is like fully lying down back. So basically for all parts, it was best to lean back a decent amount, but not fully. I think maybe when you're fully leaning back, the rectus femoris might actually be too stretched. And also I think that a lot of people experience difficulty generating enough tension. If you're sitting, you can kind of pull yourself into the leg extension and you have something to generate force against. And if you're lying down, that's a bit difficult. So I think that might also just be a practical concern. In any case, it's definitely ideal based on this, based on the 1RM values, based on the muscle activation values, to lean back about 45 degrees. Now, as I said, they also measured subjective muscle activation. Basically, they asked the bodybuilders, how easy is it to contract the muscle? Like, how easy is it for you to activate the muscle, essentially? And the bodybuilders were, in contrast to the researchers' expectations, not that good at telling which parts of the quads were more active in which positions. In my view, however, actually the findings were surprising in the other direction. The bodybuilders were a lot better than I expected, because I'm pretty skeptical of people's ability to just, introspect and say, oh, hey, this part of the muscle is more active or not. In fact, if you just, a lot of people ask you when you do a new exercise, like, what is this for? Which inherently means you cannot feel internally which parts of the muscle or even which muscle is active. Of course, this can improve with training experience, at least that's the idea. There's not much research on this. Anyway, let's get to the findings, because these were bodybuilders, they should be good at this. So here you can see a similar graph as the other one, but for the NRS scores, which is like the subjective muscle activation score, instead of the objective muscle activation score. And you can see that the pattern is kind of similar for the proximal part of the rectus femoris. It's even statistically significant. So basically for the proximal part of the rectus femoris, they were pretty capable of identifying which parts of the muscle were more active than other parts, and to identify that the rectus femoris actually did activate more. The proximal part is more near the hip. Distal part is more near the knee. For the middle part, it was not statistically significant. So while on average, if you look at these trends, the researcher said it wasn't good, I would say actually this trend does match up with the objective muscle activation trend. It's very similar to the graph I showed you earlier. You can see the graphs are very similar, but not statistically significant. And that means if you look at the individual dots, they are kind of scattered all over the place. So while the group average may be okay, which means that if you ask 15 bodybuilders, you have them do the exact same thing. You ask them which parts of the muscle were more active than others, or which muscles were active. They will be okay at that. But if you ask any one individual, you should be pretty skeptical of what they say. Now, it gets worse from here on. For the distal part, they basically could not identify a difference in muscle activation, even though there was one. So the bodybuilders were simply incapable of saying that near the knee, the rectus femoris was also actually activating more. Now in here, and this is what the research didn't emphasize that much, but here in the table you can see all the values, and you can see also for the vastus lateralis and the vastus medialis. So the vastus lateralis is like the quad sweep, this area, and the vastus medialis is like the teardrop mostly over here. So they found that the vastus lateralis, as you can see here in the table, had a similar trend for both proximal and distal to increase, for distal only a little bit, basically more and more as you sit more and more upright. And I think what happened here, this was not statistically significant, but it's definitely a trend, I would say. It's for both of the regions, and it's just going up and up. So I think what happens is, the more upright you go, the more you isolate, the more you isolate the vastus lateralis and the vastus medialis, and the result is that it seems like they activate more. So for the vastus medialis, actually, yeah, it's the same trend here. It also seemed like it activated more, or the bodybuilders thought it activated more. And I think what happens is, because they are more isolated, because the rectus femoris is less active, they think that the other muscle groups are more active. So they are confusing isolation with higher activation. And I think a lot of people do this, which is also why they think that isolation exercises are inherently superior for muscle growth, but a lot of research shows that compound exercises can be just as effective in various settings. So it's not necessarily the case that if you involve more musculature, you decrease the target musculature. Like if you do chin-ups, for example, doesn't mean that the biceps has to be less active than when you do a biceps curl. And also when you activate the biceps more during a certain chin-up variation, that does not mean that you activate the lats less. Muscle activation is not mutually exclusive. It's really important to pay attention to the biomechanics here rather than your subjective sensations. And the researchers also concluded this result indicates that the sensation of muscle contraction and the T2 value, so basically muscle activation, did not always coincide, even in trained participants, bodybuilders even. Therefore, strength training with only the subjective sensation of muscle contraction to indicate rectus femoris activation, I would say probably in general, may not guarantee training effects. So basically they're saying, which is the second big take-home message of this video and this study, that it's very, very difficult as an individual to accurately identify like specific parts of a muscle that are more active or the effect of relatively small changes in your exercise technique, and to assess like subjectively, internally, introspectively, what exactly the effect is of that minor intervention. You should take your feelings with a big grain of salt, essentially. Based on this study, there is definitely something to your feelings, which is already kind of surprising because this is one of the first studies that actually, I think the first study that really accurately does this, measure the relation between objective and subjective muscle activation. Yeah, there is definitely something there, but it's rough, especially at the individual level. The bodybuilders were not capable of, in some parts of the muscle, identify any difference when there was one, and it's a significant difference. And I think, based on this, that they were confusing isolation with higher activation. So in general, it's not the case that we have some meter inside our body that just says like, okay, now this muscle is activating at 8 out of 10, this muscle is activating at 6 out of 10. We have to kind of indirectly look at other signals. We're very prone to confusing metabolic stress and stretching as indicators of muscle activation, even though that's not necessarily the case. So, all in all, big two take-home messages. One, when you are performing your leg extensions, lean back about 45 degrees in your seat. Typically that means that you want to push back the back seat as far as it can and then fully recline, grab the handles and then do your leg extensions. If you want to lean back a little bit more, that's also possible. The optimum seems to be in between 45 degrees and 0, which would be fully lying down. It is never ideal unless you want to, for some reason, take out the rectus femoris of the movement to like sit at 90 degrees fully upright. And secondly, take your feelings with a big grain of salt. Your muscles don't care about your feelings. It's just a very rough measure of what the muscle is actually doing. Just because you feel an area more does not necessarily mean that the muscle is activating more. And more importantly, based on this study, it is very possible that some muscles are activating more, but you simply cannot feel it. All right, I hope this helps you get bigger quads. If you like this type of content, I'd be honored if you like and subscribe.